Okay, so look at the figure very carefully, and the question is, in the following figure, the line ABCD, this dotted line which you can see, line ABCD is perpendicular to PQ. Let us plot that, where P and Q are the centers of the circles, right? These two are the centers of the circle. Then we have to show that AB is equal to CD. This small portion AB is equal to this small portion CD, right? To do that, let us assume this intersection point of dotted line as well as PQ as, let us say, M. If this M is the intersection point, then instead of looking at it this way, let us try to look at it in another way. If you look at only the small circle with center P and just the length BC of the dotted line, then you will see that BC will become the chord of smaller circle with center P. Okay, now PM is perpendicular to this chord, right? And P is the center of the circle. So now, using the property of chord of a circle, we can conclude that M is the midpoint of BC, which means that BM is equal to MC. Let us remember this equation, call this equation 1. Now, go to the bigger circle with center Q, right? Now look at the entire dotted line AD. AD for bigger circle becomes the chord, right? And MQ becomes the perpendicular drop from center Q. So now again, using the property of circle, we can conclude that M is what? M is the midpoint of AD chord of circle with center Q, right? So if that is true, then AM should become equal to MD, right? This is our second equation. So now, using these two equations, we can very easily see that AB is coming out to be equal to CD. And how's that? Just subtract these two equations. Just subtract equation 1 from equation 2. So what will you get? You will get AM minus BM. And on the RHS, you will get MD minus MC. Look at the figure. AM is this complete length. If you subtract BM, you will be left with what? You will be left with AB. Now look at MD. MD is this complete length. If you subtract MC from this, you will be left with this small length, which is CD. This proves that AB is equal to CD. What is the second part? The second part is we have to show AC, A to C is equal to B to D. So this should not be a problem at all, because if we already know that AB is equal to CD, we have already shown this in previous part, right? So we can use it in second part. We already know that AB is equal to CD. So if I add BC on both sides, that should not cause any problem in the equality, right? So what can I get? On adding BC both sides, I should get equation something like this. AB plus BC becomes equal to BC plus CD. But AB plus BC can be written as AC and BC plus CD can be written as BD. This proves our second relation, where AC becomes equal to BD.